Aló, 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 hello. Hello, can you hear me?
Okay. Hello.
Hello?
Yes. Now it's working now. Sorry for
Good.
the late. My laptop has an issue. I'm able to fix it now.
Okay. Good.
Yeah. Okay. Um.
What is the issue?
Before it was the mic that has issue. It was muted, so I'm trying to put it on mute, but it was not allowing, so I have to restart the meeting again.
I see.
Yeah. Okay. Okay. So um, uh, we have Rock that is also joining us.
Good.
Yeah, is working now. Yeah. So Rock is joining the meeting, and um, I wanted to, before we start, I wanted to discuss some idea. So the purpose the purpose of what we are doing is uh, to evaluate CVA for an American option, and we are using the least square method. And inside the least square method, what I'm reading and I'm getting so far is they try to estimate the expectation conditional expectation using some polynomial uh, and I'm trying to see if when I also read from other paper that that polynomial is not actually very accurate in terms of efficiency. So maybe one way is to look at artificial intelligence neural network in order to estimate this conditional expectation. Maybe we can do a study there that could in the journey of evaluation of CVA. So that's one idea that I'm having. So I don't know if it has already been done before or still an open question.
Well, I mean, yeah, you gave a summary, but I can put some clarification. There are a few things. I mean, you could consider this like, just like a training to understand a little bit how
Oh,
things happen.
okay,
So the first thing is not has nothing to do with CVA. It's just to do the pricing of you said American put option or American call option, or
okay,
you could say any early termination payoff. So payoff where you could call before the maturity. They call it early termination or callable payoff.
okay,
So one of those are not actually the most I mean the most challenging one is what they call Bermudan option, and they do that a lot with swaps. So
okay,
you find out very quickly if you keep doing this quant work. There's a product that is very common with interest rate swaps because of mortgages. Bank need to buy an interest rate swap from other hedge fund or the thing. So, and then when you have interest rate swap, sometimes they do something which is called a Bermudian option, where they can actually uh, have an option to go into the swap or not.
okay,
So that's a very common one when you use this method, least square
okay,
method. So the idea to do is to understand how the these method work,
okay,
and try to implement it to understand. Then the CVA is called American Monte Carlo. The reason I mentioned that is because if you understand the early termination or callable option pricing, you will understand the American Monte Carlo, because American Monte Carlo is more generic. It's a more
Mm.
generic. There are two key feature in there where we say that we call it is a backward propagation. It's called
Mm.
backward propagation because you've seen that we suppose that you've not called. So this is where the conditional expectation come in. Suppose
Yeah.
that you've not called at all until the end, and then you have the value at the end, and then you go to one value, you step back. Now you can just suppose that you've not called until to that value and see if you're going to call just one day before the expiry, assuming you've not called until that day. And then you just need to compare what would be the value if you had went until the expiry and if you have called just one day before. And then you could use that approximation to decide there, and then
Mm.
go one step before and do the same thing until you get to the beginning of the option of the expiry. So
Okay.
that is the idea that you need to understand
Yeah.
and implement.
Yeah.
Then the other thing about least square, how you do the regression, linear regression.
Mm.
There are many things. I mean, here you're doing order two linear regression using only polynomial.
Yes. Yeah.
Yeah, there are other things where you could use M-mat polynomial, more complex orthogonal polynomial to do it.
Yeah.
There are cases where people go even to order three or four polynomial.
Yeah.
And you also mentioned that there are other things where people do machine learning, etc., etc. So
Oh,
to think to understand that the very important thing is do order two polynomial,
mm-hmm.
yeah, and
Okay.
use only linear regression. That is what is done in production.
Okay.
That is what you do today to get your CVA or your pricing. I've never seen a bank using a more than level two polynomial or using machine learning. I've never seen that. Now, sometimes people would do PFE. You understand, PFE is the capital of the CVA, because I told you CVA is more of the PNL, but you
Yeah.
also use the CVA for things like FRTB. There's a measure called PFE if you have your IIM, internal model approach
Okay.
for capital CVA. They sometimes use level polynomial 3 to 4.
Okay.
Just because they are looking at the tail, they need a little more precision there. Those people usually they kind of increase a little bit of the dimension of the polynomial.
Okay.
But in front office, it will be level 2 because I can tell you something. Even with only that, is
Mm.
already too much data that you need to manage. Because think about it, now you're only doing equity, you're only looking at what underlying. In the real life, not
Mm.
only you have a lot of different equities, but you also need to add the interest rate, you need to add the FX, and interest rate are for many currencies. The FX are for quite a few pairs. So basically, when you say all the two, you also have the cross product. So if you only have only two underlying, let's say equity and interest rate, let's say only euro interest rate, you have equity, you have the constant one, then you have equity and equity square, you have euro and euro square, and you have equity times euro. You have a cross product.
Okay.
There's already a polynomial that has 7, 6, 7, something like that,
Okay.
coefficient that you need to calculate.
Yeah.
Now if you also have FX in there, let's say euro USD, then you do again your USD, your USD square, cross product your USD equity, cross product your USD and interest rate.
Mm.
So your matrix is already 9. So it just grew like that exponentially. Let's suppose you want to do degree 3. So you have all the number, you have all the cross product is just gonna be a massive matrix. And when you have a real portfolio, I can tell you is already huge. So even just that, believe me, it's a lot of work, it's a lot of data, it's a lot of calculation. Calculating CVA can take the whole night just to evaluate a portfolio. So that's why
Okay.
people keep it simple, so
Okay.
that at least you get some number. Now, I've seen people doing machine learning. Usually, you give machine learning to intern. You know, you want to give them a project to kind of work a little bit on it and compare what they do. When I was in Natixis, an intern was working on a machine learning for least square. You do get some decent result, but it's like for a small project where he's doing that on one payoff. But if you want to put that in production, forget it.
Okay.
It's never, never gonna go to production to calculate, because it's expensive. People don't understand. I mean, it's not gonna work.
Hmm.
Yeah.
I see. Okay. Thank you. I understand. All right. So let me share with you what we discussed last time, and you asked me. Uh, okay. Okay. So before even I share the notebook, I just want to also confirm some things on the algorithm itself. In the algorithm, as I was discussing last time here, they stop at the step e equal to 1. That means that when we are implementing the backward, we start from the maturity, we go backward until we stop the time before the initial time that it has started. So if in our situation, if we set the maturity as 3, so we have T0, T1, and T2 and T3, we are supposed to stop at T equal to 1. And then for T0 now, if you want to fill the column for T0, we just need to take the value that we get at T equal to 1 and multiply by the discount factor here. So that's what is happening when T equal to 0. But inside the algorithm itself, we do the cash flow matrices. We stop implementing, we stop in the process of generating the cash flow when T equal to 1. That's from the algorithm. And even
Yeah.
what
I
I
mean, it's the same thing, because you need
okay,
to, like I said, when you, let's say you are at, when you look at the last day of the option,
yeah,
you suppose that you've not called until the day before,
yeah,
and then you want to decide if you're going to call on the day before or not.
yeah,
Yeah.
yeah,
So you do your regression. So when when you go, when you reach the next day, so the options start today, and then
yeah,
you've made a decision on the next day. You
yes,
know if you're going to call or not already.
yeah,
So you do again the same thing. You're on the next day, and yesterday was the first day.
yeah,
You need to know what is the value. Shall I call the first day, or just discount it, the value? On the first day, you cannot call, because it's the day you're doing the deal. You
mm,
cannot just sign the paper and say, okay, now I'll call it now.
mm,
So
yeah,
because on that day, the conditional probability is 0. You cannot call.
yes,
That's why you just discount. You don't do the
yes,
expectation, because on the first day, you're not allowed to call, basically.
yes, exactly,
So
yeah,
you just discount. But it's the same thing, because even on the, let's say you're looking at the last day,
yeah,
and you've only decided the day before, you have two options:
mm,
or you discount, or you
mm,
use the payoff. So if the continuation value is big, then you discount. But if the
Okay.
continuation value is smaller than the payoff, you use the payoff. Or
Okay.
yeah, you use the payoff, which is you call. Using
Okay.
the payoff mean that you call.
Okay. Yeah. All right. So that's one thing that because from what we were discussing before, there was a bit confusion what is happening at t equal to 0 in my cash flow matrices. Yeah. Okay. So I want to share now the notebook. Um,
But for
so
t equal to 0, you need to have values, right?
yes,
That's you have value which has all the discounted value from t equal to
yes,
1.
yes, exactly. So that's
Because that is what you're gonna need for CVA.
yeah,
Because CVA is not just pricing a payoff, it's just to have a distribution for each day.
yeah. Okay. So uh, so what I'm doing here, I'm simulating the part. The first part that I have there is a first part, but the other section here is that I'm generating my own part, which I denote part 2. I write a function that generates the part with some given uh, parameter,
Yes.
and I set the parameter the initial value 100, the strike price, and the maturity. Then I have some parts, 20, I generate 20 for now. And those are the metrics, and I put it in pandas form. Panda. And later now, I want to evaluate the CVA on that. So that is what I generated. It's giving me this value. Basically, at t equal to 3, I was just doing the okay. Maybe I will present the algorithm, the code that I wrote there. Yeah. So that's what I was saying last time. But in this in this part of the code, the value of the immediate exercise. So when the payoff is greater than the continuation value, we just put in the cash flow matrices, we replace it by the exercise payoff there. But when the payoff is less than the cash flow, the evaluation, the continuation, sorry, I set the value at 0. So that's one. That's what I saw from the paper, and I put 0 here. But in case
But
it's not,
it depends. It depends
yeah.
when you say you set 0. It depends
Mm.
which value you set 0. Which value do you set 0?
Um,
Because let's
yeah,
suppose you have two values, right? You have the value t, which is the next day, and the
yeah.
value t minus 1, which is today. Okay, so the continuation value, which date is that? Is it t or the continuation value on which date? At t
At T,
today
yes,
or
today. At T,
okay? In your code, t is it today and the next? Let go up a little bit on your
okay,
code. I
okay,
want to see what t is. So if you say t starting from step minus 1
yeah,
to 0, so t is 1 day before because end step will be the last day, no?
yes, yes,
Okay. So t is 1 day before and end step, let's say, is the last day.
yeah.
Okay, so here on the I can't see, can you add the line for on your editor or no? It's not possible. Uh
Which
no, it's okay then. If you because I cannot mention a line, I can't.
Oh, let's see if I can add. Uh,
Doesn't look like they have it.
add line.
Not there. View, go to view.
View.
Show I code. No, it's not there. It's okay. We're
Yeah,
gonna
it's
do
not there.
this. So there's a line where you have table underscore T.
Yeah.
There, okay. You see what you're doing there is you basically in your matrix you discount all the values of the payoff. What is OFE?
Uh, where did you see it?
The
Okay. Yes, this one is. I first here at the beginning here. So I first evaluate the exercise
is the
payoff,
payoff.
and
Okay,
then
go down.
I copy it in another variable.
OFT
Yes, that I did not
option.
just
Okay,
OFE option,
okay.
and uh, uh, it is now from this now that I'm start building my cash flow step by step. And the first step is just to replace the last column, which is t equal to 3, by uh, the payoff.
Understand. Go
Yeah.
back to
Okay.
that table.
Okay.
So if you have OFT, so there you just discounting, there you discounted only the last day, which is T plus one,
Yeah.
into today. So it make it the value of today. Okay, and then that is you put that in table T, right? And you
Yeah.
also put the stock value today, second column.
Yeah.
Now, if you go down, ID Monety, what is that? ID Monety, if you go up.
Up.
Okay. ID Monety is just to only filter the indices of where you are in the money. Okay.
Yes. Yeah. Yes. Yes.
And then you filter your table T for those. It's all
Yeah.
right.
Yeah.
Now you do you do the polyfit and you have the continuation value.
Yes.
You have
Exactly.
the continuation value for the date at T for today.
Yeah.
Okay.
Yeah.
And now here you look at, you're gonna fill in the value T,
Mm-hmm.
the value at T. So today,
Yeah.
oh,
As here. Okay. What I'm doing here, I'm filling all the parts. I'm just filling all the parts where this condition is satisfied.
so you're filling up the part where you are in the money first,
Yeah.
and then where if the payoff is more than the continuation value.
Yeah.
So if the payoff is more than the continuation value, what do? You put
I
zero?
no, I put the exercise payoff here.
Yeah,
Then
yeah, okay, yeah, you put the exercise payoff there.
yes, but if not, then I
If
put
not,
0.
no, you should not put zero. If not, you don't do anything basically. But maybe in this case, it doesn't change. Uh, because if it's not, I will not do anything because the value in that vector is already correct. No, the value in that vector is it correct? Yeah, because the value in that vector should be basically the discounted value of the final value. It
Okay.
should be the discounted value of the payoff at T plus one. I don't know if it's already in there. Maybe it's already in there. Because normally you put
Mm-hmm.
that at the beginning, right? Right. At OFET, what do you have at first? in that table? What do you have at the beginning? OFT.
T is
You
a
see
value.
in O you see in OFE. If you go back where you define OFE,
Okay. Yeah. Here.
you see OFE here.
Mm-hmm.
You have pair of values. Yeah, you have pair of values. Basically, if you use the pair value,
Yeah.
because if you go down, where you putting because you said that if the pair value, which is already the value that you have at OFT, basically, it is greater
Mm.
than the continuation value.
Yeah.
You put the pair value. It is already actually in there. The
Yeah.
pair value should be already in OFT because you've already put them in there.
Yeah.
So if the payoff is greater than the continuation value, you don't even need to do anything because it's already there. But if it's not, then you put the discount value. That is my understanding. The zero can be useful for the what I would call the value, the t plus one value. Because think about it, if you exercise, so
Mm-hmm.
if you exercise,
Yeah.
it means that you're going to put the pair value at t.
Yeah.
And then it means that the next day, what is going to be the value?
Just I think it's the discounted payoff.
The next day,
Yeah. The discounted payoff.
because you already exercised today.
Mm-hmm.
Before you decide that you're going to exercise today, what was in the next value? It was the discounted value. But if you decide to exercise today in terms of cash flow, the next day there will be zero.
Okay.
Maybe that's what is happening actually, because your code is giving the answer, but maybe the way is doing. I'm just confused. If there is a zero to put, it's
Mm.
when you exercise, but you don't put zero at the value today, because
Okay.
if you don't exercise, so it means if you don't take the payoff, the value today should be the discounted value of tomorrow. You agree with me? It
Yeah.
should not be zero. It should be just the discounted value. But if you exercise, the value of tomorrow will be zero. Because if you exercise today, the deal is done. There is no more cash flow tomorrow. There is no more exposure. This deal is closed. So you need to go and override the value of tomorrow. This is because we're doing CVA. If you were doing just a pricing, you don't even care at that point of value tomorrow.
Okay.
Because at that point, all you care about is the value I have today. I'm going backward to the beginning. But if you're doing CVA, because you need to have your cash flow or your mark to
Mm.
market for all the days,
Yes.
then
Yeah.
when you exercise, you have to go back now and put zero for everything coming after that for that path.
Yeah. Okay. Okay.
That's maybe what this code is doing,
Yes.
because
Yes. Mm.
it put the zero for things that are coming after, not on that day, because on that day it should be the discount factor. But I think for the discount factor, it is already, uh it is already the good value, because you put the discount factor in that matrix at the top. When you created it, you put all the discount factor for everything.
Yeah.
So that is what I think is happening. But
Yeah.
you need to check that is actually doing that. You need to check 100%.
What do, so when you say check for the for the pricing when I wrote like this and if I
You see,
when
There, sorry to interrupt. There is another line here for J in the range. You put J plus 1 equal where the money is more than 0. You put 0.
Yes.
Otherwise, you put the next one. Oh, maybe this is where it does it.
So this part is because when I'm filling the table, the table, um, for t equal to 3, for instance, I have already the value in that column. For t equal to 2, I have some value after the continuation, and t equal to 1, I will be also having some value. But the thing is that when I arrive to certain part, I noticed that if I'm at t equal to 2 and t equal to 1, I will be having some value at the same part. And since we are looking at actually the time, the optimal time for the part where we need to take evaluate the average, I just put the other time at 0. So that's what I'm doing here.
So let take a break a little bit. Okay, can I share my screen? If you
Okay.
stop sharing, I share my screen. Because the thing with these vector programming is that you don't see the algorithm very well. That's why I don't like it too much, because I mean, you could implement it, but the most thing, like I said, you just need to, all I want you to do is to understand, to be able to explain, because you're programming in vector. I'm not sure it's easy. I have a code here, which is a for loop, very simple C++, which is easy to understand. Can you see?
Yes, yes.
So, okay, the first thing you want to do is to calculate the discount factor, which is constant, because here is a risk-free rate is constant, and the time state is constant. So you can have one discount factor, right?
Yeah.
You have a vector which is basically a vector of the value. So you're not having a matrix, only one value. In that vector, you're going to put all the value of the payoff. You see, this is a payoff, which is a maximum between the strike minus the value. For the last step in C++, step -1 is the last step. And J is there, the path, the number of simulation. Yeah. So you fill the last V. I now have the final payoff of your product, the final value that if you had never exercised at the end, this is what you're going to have for each path. Yeah. So it's very simple. Now, next step, you're going to go from step -2, which is the day before, until you reach 0. Yeah. Until you reach 1. So you go from the day before, you have your x's and you have your v's where you want to you need to use for your regression. You go through all the simulation. Now, this is the final value. You discount it. Yeah. Now this final value has been discounted in the vector v.
Yeah.
Now you get the value of the path x. Now, if it's in the money, because only when it's in money that it matters. If it's not in the money, you don't do it. Now you will use the value for y, and then you will use 1 x and x squared for your polynomial. Okay, you need to solve for the coefficient. If you have at least 3 values, because if it's less, then it doesn't make much sense. If you have at least 3 paths that are in the money, yeah,
Okay.
then you just solve here. You solve for your b here. And what you're going to do here is to calculate your continuation value for each path. So you go through all the paths, you get the x, you get the payoff. All right, this is the payoff for that path. Then now, if your payoff first, if is in the money, yeah, it has to be in the money. Then you calculate your continuation value, and you see here that if the continuation value is less than the payoff, V become the payoff now. What was in V before?
I think it's the discounted, right? Payoff.
Yeah, it was a discounted value, and now it's gonna be the payoff. You replace the discounted value by the payoff, and that's it. And you start again, and you go to the next path. You see?
Mm-hmm. Yeah.
So if you see here, you go to the next path, and then this is what you do for the pricing. At the end, you just discount, like you said, for the last path. You don't need to do, because here is going to 1. It's going up to 1.
Yes,
And then
yes.
for 0 now, you just discount them.
Yeah.
And then you return the price. But I think where you need to put 0 for the CVA is that here is not going to be only a vector, it's going to be a matrix.
Yeah.
Yeah, because you need the path for everything. Now, when you get to the case where you have this, not only you put the payoff, but you need to put 0 for everything coming after this,
Yes.
because this will be the last non-zero value. After it, you don't care. You have to fill it with 0 until maturity.
Yeah.
This is only where I see that you could put zeros.
Okay. Yes,
But
yes.
yeah,
Yeah.
do
That's exactly that's what I was doing there.
yeah, that
Yeah, yeah.
I just want to make sure that you're not saying that if, let's say, you don't have it, you want to do here, saying that else I'll just put vi d equals 0. No, this is not good.
Mm.
This is not
Okay.
good. You don't put 0 if it's not.
Okay.
Where you put 0 is there. You put 0 on everything there. Actually, you put for everything, for all the j more than for all the, let's say, I more than j, you put 0. So that is what you need to do. I mean, I think that's what you're doing, but you need to understand that it is what you're doing.
Okay.
Yeah.
Yeah.
Good.
Okay.
Okay, we can go back to your code now.
Okay. Okay. Yeah. So yeah, that's what this part is doing there, and then from there I just evaluate the so this part is just evaluating the option value, and
Yeah.
this part is evaluating the CVA. Yeah. So at the end, I will
So let's
get
have a look at the CVA quickly.
yeah,
So for the CVA, what are you doing? You're gonna calculate the CVA for each day,
yeah,
and then on that day you have the recovery rate, you have the discount factor.
yeah. And actually here,
What is
if
0.01?
oh, just the probability of this equal.
Okay, yeah,
Yeah,
yeah.
I just set it for every year.
Yes, usually what people do is to say that the 0.01 is like the R for the discount factor. and they use the same formula as this one.
Okay.
Exponential of not minus this time. Is it minus?
Yeah.
Basically, you could use look at some of the hazard rates. I don't know if you're familiar with hazard rate.
Not true. No, but
The hazard rate. Basically, the hazard rate is to do probability the same way you do discount factors and just
okay.
have a hazard rate. But anyway, you could use that for now.
Okay.
So you're doing 1 minus recovery times
Okay. So first of all, I denote I'm creating a list that contain my expected exposure, and it is that list. For instance, if I'm at the column t equal to 3, this will just take the average of this one and put it in the list. And I first define the list here. I empty it, and inside the loop, I'm just going through all the path and going through all the column and see the distribution at each time and do the average across all the paths. So that's what I'm doing there in order to get the expected exposure at the T.
yes, so sorry, I had a call.
Oh, okay, okay.
Uh, yes, I mean, uh, it is for this. I think this is correct, but it is more important to show step by step what you're doing because if there's something that when you do coding, if you do it like this, for sure something's gonna be wrong. 100% sure it's going to be wrong. So what you do is that you need to have intermediate result that you present. So for each step, what you're doing. So for example, what I would like to see is, especially you're using only 20 path.
Yeah.
If we could have a matrix
Mm-hmm.
of how, let's say for a couple of paths, you show just the cash flows, but with intermediate result of the cash flows. Maybe if your path probably the first one you show, the second one you show, and then you show a bit more in the middle and some at the end. Then I want to see all the cash flows and make sure that they make sense. You can explain them. And you want also to show next to the cash flow to show
Mm-hmm.
also just the payoff. So the also the matrix for of the payoff and the cash flow. This is more important than the result to make sure that you have a presentation. You can actually use it
I,
later to have a PowerPoint presentation where you present the step.
yeah. Okay.
It makes more sense than to have a code say, okay, this is the answer.
That if
Don't
you don't
even do
mind,
20. Don't even do 20. Do 8 like before.
okay,
3 step and 8 path is enough.
okay. Do you mind that I do it now so that you see the different step? Or
I think it would be good to do that and put into a PowerPoint, no?
oh, PowerPoint. Okay,
Do
okay,
that and put it into presentation. Because what we want to understand, what we want to make sure is that you could present how you will get a price, how you will get the how you will get the cash flows or mark to market. Now, what do you need to be able to get the CVA? And then you could calculate the CVA with your hand. I mean, it's three path. You don't
okay.
even need to do a sum. You can just do it's just an integral on three path. So it's just three additions. And then you say if you use this as a PV, use this as a recovery rate, then this is the value of the CVA. Yes, and you could calculate that on a presentation. I want to make sure that you understand.
Yes, actually, what I'm doing, I understand what I'm doing there. Okay, so maybe
Because I'm
what?
surprised.
Yeah,
You cannot get a PVA, a CVA. Is on the CVA on that integration. I want to see some surviving probabilities that I'm not seeing. The CVA is not the I mean, you need the surviving probabilities.
okay. What be- what do you mean survival probability? Because from the formula here, it's just the summation of the okay the discounted value with the expected exposure at a particular time t. So we are doing the summation across the t.
But what is PD?
PD is the probability at default. That's what I was
The
asking.
probability of default where?
At t at
No.
t.
Yeah, but it's not that you use a CVA. That's
And
why you need to. So you do you know the cumulative default probabilities?
yeah,
So is that the cumulative default probability?
no, this one is just the probability of default at t. And if you remember, I was asking that the first that because in order to compute it, we need this, and you ask to maybe to not to just not worry about and to set it
But no,
0.01.
yes, but you still need to understand what it is. Yeah.
Yeah. Okay.
But if you tell me the probability to default at t, then that formula is wrong. The CVA is not the probability of default at t. So PDT, usually people use that. Let's say T is 5 years. So PDT will be the probability for a company to default between now and 5 years.
Yeah.
Yes?
Okay.
But if it's that is wrong. That formula is wrong. So you need to make sure you understand that, because if you tell someone that you're calculating CVA and you don't know that, it means that you don't know what you're doing. It's good to understand what is that PD. That's why I mean, it's not. I'm not saying it's difficult to understand. It's very trivial. It is trivial. What you need usually in the CVA when you're doing your integral is the probability to default within that interval. So if you're doing every year time 1, 2, 3, 4, the PD you use there, if you're doing from 2 to 3, is the probability to default between 2 and 3 that you use for the integral. Yeah. It's
Hmm.
not the probability to default from now to 3 years. So that's
Yes.
why to do that, you need to have the surviving probabilities. So usually here you see the formula, it's not PD, it's QT plus 1 minus QT. No, it's actually QT minus QT plus 1. And QT is the surviving probability, not the default probability. So it's good to do step by step. It's actually not the most difficult part of it. Now you replace it by 0.0.01. Usually the surviving probability is within could be 1% within a year. It means that the probability to do for a 5 year is something like 5%, which is reasonable. Yeah.
Okay.
Um, but it's good to put that into a presentation to see, these are the component, and if I use this value, this will be the CVA.
Okay.
And then here you're doing the sum of all the CVA for each interval to get your, yeah, because it's an integral, you do the sum for each interval to have the total value.
Yeah.
Yeah. And do you have the time as well? You don't have the time here because it's 1 year, but you need to know that you need the time.
N- the time, no, here is 3 is 3 years. So and the step
Yeah.
is 1 year.
Yeah. So you don't have it here because it's one and it works, but you need to know that. I
Yeah.
ask you, usually step is not 1 year. Step is
Yes,
sometimes something like maybe every quarter. So you
yeah,
need to divide by 4 or something like that. So
I set it here, the step size. So in case if maybe I took t equal to 1 year, and then my number of the step size, the interval is 3 years, then my dt will just be 1 divided by 3. So that
but
will be every quarter.
do you have DT in your equation for
Yes,
CVA? Let's see.
yes, yes,
Let's see. Let's see.
yes. That is the dt. It actually,
No, no, that is the discount factor. That
you
is the
mean
discount factor.
in the evaluation of the expected exposure?
Yeah, you know you should have time DT because go back
Yes.
to your formula is an integral over time, right?
Yeah.
Go back in your formula.
Uh,
Yeah,
yeah.
it's CVA. You see, it's an integral.
Yeah.
It's an integral over time.
Yeah.
What is? I'm not sure about this formula. What is DF?
Df is the discounted factor.
Okay, discount factor. Then you have EE, which is exposure at the time, and yeah, this is DPD. Yeah, DPD will be usually the probability, the change in probability in the interval.
Yeah.
It would be good to get a good definition from a good source of the CVA. So it's a definition that is because this one with PDT is not correct. It's not PDT.
Sorry.
DPT, yeah, it's not PD. You need to get the correct value there.
Uh, so, sorry, I may be confused. What you say? You say PD here is just is a continuous time when
Yeah.
continuous, but here is the discreted when we discrete the time with some step. So um, this here is just the discounted factor that using exponential of minus RT depending on it, and the expected exposure at time t. That's what I'm evaluating using the Monte Carlos, and PDT here is I think is a probability of default at time t. So for that one, I didn't. I just set it at maybe a constant value. Yeah, but here, the place where I'm using uh, my DT, I already set my DT here as the maturity divide by the number of steps that yeah. So if it is 1 year, then every quarter we get the DT, which might be a decimal number here. And from there, when I'm evaluating my expected exposure, uh, yeah. Okay, so here is just the price to have to multiply by the DT using this. This is just the part of the discounted factor, and even inside uh, the CVA, the only part where the discount factor intervene is this part.
Yes. I mean, I know why the problem is there because so let's say that if you change ET, you see that the 0.01 doesn't change. It's always I mean, if we say that that is for 1 year, now if you change, it will be also for 1 quarter, the same thing,
Yes.
no?
Yes.
So that's why I was saying the GT also impact the probabilities, not only the discount factors. There is not impacting. Though, so usually what people do is that you use let's say they give you a hazard rate. You need to find out what is the hazard rate of
Okay.
one hazard rate of sometimes people call it default intensity of maybe let's say 1% default intensity, and then use that.
Okay. 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 All right. S-
I
Okay,
need to
so
jump
so
to another call.
yeah, and okay, in summary, what would be the next step now?
Is to
uh,
do a presentation on it. We've run a code with just 3 path, no, 3 dates and 5 path, and then present the results step by step on maybe a PowerPoint or something. But you still need to finalize your code, and then you extract the. You can even do a screenshot and put into a presentation, so we can have a little discuss. We can still discuss on the a bit like the article that you show me. You see what
yeah.
they did? Yeah, do it with your own simulation,
Okay.
and then that will be useful to do a presentation.
Okay.
I don't know. Is Kofi still on the
No,
line?
he no he I think he left.
Okay.
Yeah. Okay. That's right. So I will do that, and we can organize another meeting, maybe
Yeah,
at your
sometime
free
next
time.
week.
Yeah.
Yeah, we could do sometime next week.
Okay. Okay.
Yeah.
So I will just need to. I think here the most important part here is just to incorporate the priority the default to be
Also
right
to see the cash flows.
on the
I
cash
want
flow.
to I want to see for each step the cash
Each
flow, so we could see the cash. What I mean by cash flow, I need to see the cash flow and the only payoff to see if they make sense.
okay, the cash flow and the payoff. Okay. All right. Yeah, that's right. Okay.
All right.
So maybe
Okay.
maybe you can meet on Monday or maybe Monday.
Wednesday should be fine.
Oh, okay, Wednesday. Okay.
Mhm.
All right.
Thank you.
Yeah. Bye bye. Thank you.